Okay, so let's continue previous session. We already discussed about the rotor EMF induced at a standstill and at any particular slip S. Okay, as well as we already find their rotor leakage reactance at a standstill, that is represented by X2, and at any slip that is represented by SX2. Okay, corresponding to that EMF and impedance, we already find out the rotor current, that is I2 at a standstill and at any slip. Yes. Now we just try to find out what is the power input to the rotor circuit. Okay, and what is the equivalent circuit of the rotor, whatever we have EMF induced and rotor circuit impedance, that means leakage impedance. And so just try to share the screen and then we will continue our discussion. Okay, so just wait few minutes. Okay, so up to this point we already discussed in the previous class. That means rotor EMF induced at a standstill and at any slip S, and rotor leakage reactance at a standstill and any slip S. Corresponding to that, we already find out the rotor current at a standstill, that is nothing but E2 by square root of R2 square plus X2 square, and at any slip S, the current is equal to AC2, that means EMF induced is replaced by AC2 in place of E2, is it not? And the impedance is represented by R2 square plus SX2 square in case of any slip S. Okay, so this is the value of E2. Corresponding to this value, we can just simply draw the electrical circuit. What is the equivalent circuit for this equation? So just look like this one. Okay, so this is the equivalent circuit of the rotor, where the EMF induced is represented by E2, and I2 current flow through the rotor conductor, and rotor leakage reactance represented by X2. Okay, and this is represented by R2 by S. That means this equivalent circuit is drawn corresponding to this equation. That means rotor current I sorry, I2 equal to this one at any slip S. That means the circuit is drawn at any slip S, okay, not at a standstill. If you want to draw the rotor equivalent circuit at a standstill, that means corresponding to this equation, okay, at corresponding to this equation of the rotor current, that means simply you have to replace the circuit here. That means rotor resistance part, that means this R2 by S simply just replaced by R2, is it not? And all the parameters are same. That means EMF induced is E2 and leakage reactance X2, and current flow, that is nothing but I2, and rotor resistance will be represented by R2 simply for a standstill condition. And this one is drawn at any slip S. That means rotor running at a particular speed. Okay, so that condition we already drawn here the equivalent circuit of the rotor. Now we want to find out the rotor input power. That means whatever the how you can power supply to the stator winding, already explained in the operating principle of three-phase induction motor. Okay, so how much power input uh, from the stator to rotor transfer? Okay, that is represented by some standard notation. That means, so one more thing we can explain here. That means if this is your circuit, the rotor current I2, that means this one I2 lags the rotor rotor voltage E2, because the circuit is RL, is it not? This one is your R and this one is your L. So obviously the current lags E2 by some angle, that is nothing but that is represented by theta 2, equal to how much? Resistance part divided by reactance part. Okay. So you may be right here. That means how much the rotor current lags this rotor EMF induced voltage E2. So that angle is already how we can find the angle in the RL circuit. Okay. So the rotor current, the rotor current I2 lakhs the rotor voltage E2 means rotor current I2 lakhs the rotor voltage E2 lakhs the rotor voltage E2 by an angle theta 2 that is represented by E2. No. By rotor power factor angle theta 2 by rotor power factor angle rotor power factor angle theta 2 so this theta 2 equal to nothing but how much? Theta 2 equal to 10 inverse resistance by reactance part by resistance part. Okay. So equal to 10 inverse Sx Sx2, this means x2 divided by r2 by s. So this s we can transfer to the numerator part. Okay, so we can just write here, that means Sx2 divided by r2. Okay, so Sx2 divided by r2 divided by r2. So what is the total power transfer from the rotor to stator to rotor part? Okay, so just we can write here, that means this is your circuit equation circuit. So we can write here rotor input power, that is represented by P suffix G, rotor input power just maybe right here, that means rotor input power, that is represented by PG, rotor input power So how we can write the power in AC circuit? As you know that means the product of voltage into current into power factor. Okay. So your voltage value is your E2, E2, current is your I2, oh, sorry, E2, and current equal to I2, I2 into cos theta 2. Good. Cos theta 2. So this is total power input to the rotor circuit. Okay. Now we can simplify this equation as we already find the value of I2 a few minutes earlier. So just put their value here, or you maybe just write the value of cos theta 2. Cos theta 2 equal to how much? For the circuit, if your tan theta 2 equal to sx2 by r2, then you are able to find out the value of cos theta also. Is it not? That means r2 divided by r2 by s into square root of r2 by s whole square plus x2 square. Is not? So from this equation, you are able to find out the cos theta 2 value. So just put here the cos theta 2 value. Okay. So as we know that, as we know that cos theta 2 equal to theta 2 equal to r2 by s r2 by s the square root of r2 by s whole square plus x2 square. So square root of r2 by s whole square r2 by s whole square plus x2 square plus x2 square x2 square. So just put the value of cos theta 2 equal to this one in this equation, then you are able to simplify. Then we can write here Pg equal to that means rotor input power Pg equal to E2 Pg equal to that means E2 I2, put here E2 I2 I2 into cos theta 2. Cos theta 2 equal to R2 by S divided by this one. So you can write in numerator part R2 by S is not, and in denominator the square root of R2 by S whole square plus X2 square. So R2 by S whole square R2 by S whole square plus X2 square into R2 by S, this one is not, into R2 by S, R2 by S. Not. As you know that this one E2 divided by a square root of R2 by S whole square plus X2 square can be replaced by I2, is not. So this equation, if you simplify, then we can just write for PG equal to, that means rotor input power, that is represented by PG equal to I2 into I2, so I2 square, is not. So I2 into I2, I2 into I2 I2 into R2 by S, R2 by S R2 by S. So can be written as this one I2 square R2 by S. Okay. So I2 square R2 by S R2 by S. So as you know that in the power equation in the ratio part, that means I square into R. Okay. So in the place of R, you have here R2 by S. So that's why here power equation becomes I2 square R2 by S. Okay. As we know that the reactance part consuming no power, that's why it becomes I2 square into R2 by S. Okay. So the per phase input to rotor is equal to I2 square R2. So the per phase power per phase power input to rotor input to rotor is equal to I2 square R2 by S is equal to I2 square R2 by S R2 by S as the reactance X2 consume no power as the reactance no power okay. So PG is the power transfer from a stator to rotor across the air gap. You know. So PG is the power transfer from the power transfer from a stator to stator rotor across the air gap across the air gap. In view of this, PG is called the air gap power also. In view of this, PG is called the air gap power. PG is called the air gap power. Okay. Air gap power. Okay. So PG equal to I2 square R can be simplified in such a manner that we can find another part of the power, that means some part of power losses take place as the rotor ohmic loss, and remaining as the develop as the mechanical power in the rotor part. Okay, so PG can be simplified. That means PG so just you try to simplify this equation. PG equal to I2 square R2 by S equal to I2 square I2 square R2 by S R2 by S. So this one can be written as I2 square R2, I2 square R2, I2 square R2 plus I2 square R2 into 1 minus S by S, I2 square R2 I2 square R2 into 1 minus S by S into 1 minus S by S, 1 minus S by S. Not can write here, na? So 1 by S minus I2 square R2 and this I2 square R2 plus I2 square R2 cancel out each other. So the remaining part is I2 square R2 by S. Okay. So this part is known as the rotor ohmic loss, and this part is known as the internal mechanical power developed, that is PM. Okay. So this one can be written as rotor ohmic loss plus rotor ohmic loss plus internal mechanical power developed, internal mechanical power developed. This one represented by PM. Okay. So this one represented by PM. Okay. This equation can be simplified such as this one is SPG into 1 minus S into PG. So PG can be simplified as PG equal to we can write here SPG SPG plus 1 minus SPG plus 1 minus S into PG. You know, this is the same thing, huh? PG equal to SPG plus PG minus SPG. So minus SPG plus SPG is cancel out. So PG equal to PG. Is it not? So PM equal to, we can write here PM equal to, that means mechanical power developed equal to how much? 1 minus S into PG. Is it not? Or I2 square R2 into 1 minus S divided by S. Okay. So rotor, that means PM equal to so you may be right here, that means SPG equal to rotor ohmic loss equal to SPG also. So rotor ohmic loss is equal to SPG is equal to SPG SPG and mechanical power, that means develop equal to internal mechanical power, that means PM equal to right here PM is equal to 1 minus S into PG 1 minus S into PG or I2 square R2 into 1 minus S by S. I2 square R2 I2 square R2 R2 into 1 minus S by S into 1 minus S 1 minus S by S. So this is the mechanical power developed in the rotor. Now we can just find out the value of torque, electromagnetic torque developed in the rotor, that is T equal to Pm by omega r. Okay, so internal torque developed, that means internal torque developed in the rotor, developed in the rotor can be represented as T equal to Pm by omega r. Okay. T equal to Pm by omega r Pm by omega r So just put here the value of Pm equal to 1 minus S into Pg. Pm equal to 1 minus S into Pg. Pg, as you know that omega r can also be replaced by 1 minus S into omega S. Okay. So just put the value of omega r in terms of omega S. That means 1 minus S into omega S omega S. Okay. So you can write here Pg by omega S. So Pg by omega S omega S, or omega S can also be replaced by 2 pi ns, that is 4 pi f1 by t. Okay. So if you simplify this equation, then you are able to write the torque equation, that is equal to 1 by omega S into I2 square R2 by S. Is not? So 1 by omega S omega S into I2 square R2 by S into I2 square R2 by S, I2 square R2, just I2 square R2 by S R2 by S. So this is the torque equation, 1 by omega S into I2 square R2 by S. You may be simplify this omega S equal to 2 pi ns or 4 pi f1 by S p. Okay. So you maybe also write here 1 by 2 pi ns into I2 square R2. Okay. Equal to 1 by 2 pi ns 1 by 2 pi ns into I2 square R2 by S into I2 square R2 by S. I2 square R2 by S. So stop here. In the next class, we will continue from this point.